Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with number 26 in your Unit 2 homework. Right? So this is about this object that starts here at what I've already kind of drawn into position 1. Apparently it accelerates down this incline, and here's a picture of it here at position 2. Now the first question here that says to sketch a velocity graph and find the final speed of the crate. So start with, draw yourself an axis like so. It just needs to be a sketch, velocity against time. Now it starts from rest. That should tell you where the first point is. Now to calculate the second point, which is 2.2 seconds later, the 2.2 is given, but you're going to have to calculate the V final. Now, what everybody loves to do right away is take the 4 meters and divide by the 2.2 seconds, and this is fine, but what you need to realize is what that does. That calculates the average velocity, not the final velocity. That's not the one you need for this graph. Now, to get the final velocity, remember that your average, right, if the acceleration is constant, can be written v initial plus v final over 2. This is true anytime your acceleration is constant. That should allow you to get this graph finished up. Okay, now for part B, where it says to use principles in energy to find the average frictional force acting on the crate. Okay, well, if we compare position 1 and 2 and we write out the work energy theorem and we assumed no frictional forces, you would end up with an equation that looks like this basically. And you're going to end up with a V final larger than the one you calculated here. And what that means is, why would that occur? That would be telling you, oh, there's got to be another force you're not taking into account. So write out the work energy theorem. PE1 plus KE1 plus work 1 to 2 equals PE2 plus KE2. If I were you, I would datum out PE2. You should have terms for the PE1, okay? Starts from rest. That should tell you something about this. Again, we datumed that out. And then the KE2 is your kinetic energy term. Now for the work term, draw a free body of this object. Imagine it right here. And now start putting force vectors in there. And you should end up coming to the conclusion that there are 3 of them. Now, the gravitational force does work in this problem, but that's what the potential energy takes into account for you. So that's already done. You don't need to worry about that one. There's a normal force. You have to ask yourself, does that do work? Yes or no? And then you should have a frictional force. And then ask yourself, does it do work? Yes or no? And if the answer is yes, remember, work can be written force times distance, and put something there under the work term for that frictional force. And don't forget to include a plus or minus sign on that work term. So that should allow you to hopefully calculate that frictional force. I got 66 newtons when I worked it out. Let me know how I did. All right. Part C, where it says how much mechanical energy was lost. So, and I even gave a hint here. Calculate a number for PE1, and then calculate a number for KE2. And the difference between them is how much was lost. If you got, I'm just going to make up a value, 100 joules for PE1 and only 80 joules for KE2, that would tell you 20 joules is lost. So anyway, that's what I'm getting at there for part C. I think I'm just going to end that video. That's probably enough for this one. I hope it helps. Have a great day.